All right, everyone that missed class, I want to summarize the notes that we did in class, kind of using this video. Obviously, during class, we build it up a lot more. Still, hopefully, by watching this video, you can understand what we talked about. What we talked about were tides. Tides are caused by the gravitational force of two things: the moon and a little bit of the sun, but mostly the moon. So what we did is we drew this. We drew Earth, and then we drew the moon. And as the moon is spinning around the Earth, it creates this gravitational pull. And wherever the moon is right now, what it's doing is it's pulling water to the moon. It's pulling water to the moon. So where that water is being pulled to creates a high tide. And where that water came from makes a low tide. So wherever the moon is, like right now, like directly underneath that moon on the Earth, there's a high tide. It depends where that moon is. If the moon's over here, there's gonna be a high tide right here. Try to wrap your head around this. I'm not a physics guy, but because the Earth is spinning, it creates this thing called centripetal force, and it creates this centripetal bulge. And on the exact opposite side of the Earth, where there's a high tide, there's also a little bit of a high tide. So there you go. We drew that on our notes. And then what we said is that the tides are created by the gravitational force of two things: the sun and the moon. And next thing on our notes, it says as a tidal cycle. A tidal cycle is a high tide, then a low tide, then a high tide, and then a low tide. Two high tides and two low tides. And when they happen, every 24 hours and 50 minutes. Okay, that's the first two parts of our notes. Then the next thing on our notes is we went through the tides on February 1st. Here are the tides on February 1st. 5:58 a.m., the tide was 13.0. At 11:17 a.m., that tide was 7.1. What do those numbers mean? Well, to understand what those numbers mean, we drew the beach. And then we drew a dotted line. And we labeled that dotted line 0.0. And what 0.0 is the average low tide. Think about it like this. Think about it like a marine biologist. They went down to the Golden Gardens every single day, and they waited for the tide to go out. And then when the tide went out, they put a flag in the sand. And after 365 days, there was a lot of flags in the sand. And they averaged them out. And they said, this is it. It's this thing. And they painted a rock orange right here. They said, this is the average low tide. This is 0.0. So now that we know what 0.0 is, we can understand the tides on February 1st. On February 1st, the tide at 5:58 was 12.0. What that means is that it was 12.0 feet above the average low tide. I mean, you would have to get in the water and you have to dive down 12 feet to find that orange rock. So, obviously, that was a high tide. Bam! We talked about 5:58. And then at 11:17, the tide was lower. It was like, well, let's leave that here and let's draw a new tide. At 11:17, the tide was right here. It was at a 7.1. Now, since the water level went down, this is going to be a low tide. Now, it's still not that good of a low tide. You still have to dive down 7 feet to get to that orange rock. So you're not going to see any starfish. You're not going to see any cool things down at the beach, but it's a low tide. Bam, talked about 11:17. Then at 3:58, the tide went up and went up to 10.5. Oh, since the tide went up, this is going to be a high tide. Bam, talked about it. Then at 11:05 p.m., oh, now we're getting somewhere. Now the tide is 0.5. Oh, since the tide went down, this is going to be a low tide. And this is a pretty good low tide. You're going to see stuff down at the beach. So that's what the numbers mean. And we just talked about a tidal cycles, a high tide, a low tide, a high tide, and a low tide. And they happen every 24 hours and 50 minutes. And that's what we got. A high tide, a low tide, a high tide, and a low tide. It happens every 24 hours and 50 minutes. Next thing, on our notes, it says there's some special tides. And the special tide, first one is the spring tide. And spring tide, by the way, it doesn't happen just in the spring. It happens all year long. A spring tide is a really high tide and a really low tide. Then what we did on our notes is we drew the earth. And it's caused by two things that make gravity on the earth being lined up perfectly in line. It's caused by the moon and the sun being a perfect line. And that creates the greatest gravitational force on the earth. And it creates these really high tides here and really low tides there. Then we came up with like an example in the class, like, well, if February 1st is an example of like normal tides, like the highest tide we got was 12, and the average low tide is somewhere around 0, what would the numbers be for a spring tide? Well, it's got to be higher than 12. I don't know. Maybe it's something like 18. And a low tide, it's got to be lower than the average low tide. Yeah, so it's gonna be in the negatives. It might be something like a -4. Oh, great time to go down to the beach. You're gonna see stuff this time. The next type of tide is a neap tide. Neap tides are a not so high and a not so low. It's caused by the two things that create gravity on the earth working against each other. It's caused by the moon, the earth, and the sun making a right angle. What's happening here is that the moon is trying to pull water right here, and the sun is trying to pull water right there, and they're working against each other. And it creates the not so high tide and not so low tide. In class, we came up with an example. We said, what would the high tide and low tide numbers be during a neap tide? Well, if average was around 12, it's not going to be that high. It's going to be something like maybe like an 8. And the low, it's so not going to be low. Like maybe it's going to be like a 6. So there's really not that much of a difference between the high tide and low tide. I'm going to stop our video here, and I'm going to talk about the next part of our notes, how to generate electricity.